Hello everyone, welcome to today's chemistry class. Now, today on chemistry, we'll be treating Jamb past question 2023. But before I do that, I'd like to quickly bring something to your notice. Now, look at this. That's Kstudy Exams. Now, this you can find on the Play Store. Now, this is going to help you in your Jamb. It's going to help you deal with issues on your Jamb. I know there are a lot of questions that can be very tricky in Jamb, and you see them and you're wondering what you're going to do about them. With your Kstudy Exams app, this app will enable you to ease your Jamb without stress. Now, with that being said, I'm going to quickly clean this, all right? Then we are going to go straight to our question. Now, we are dealing with Jamb past question 2023. Question number 1. What is the symbol used to represent an alpha particle? A, there's a sign like a small a there. B, you have like a Y. C, you have like an S. And D, what I call a capital B, but it's not a capital B. All right, the answer is A. That A, number 1, A is an alpha particle. When you take a look at the past question, you see you have an alpha particle. All right. Now, the other signs represent there. If you look at the D, D is called the beta particles, and the Y is called the gamma. Now, question number 2. When a substance is oxidized, it is dash. A, loses electron. B, gain oxygen atoms. C, gain electrons. D, loses proton. Now, if you take a look at what you've studied through chemistry, you understand oxidation and reduction reaction. And from the few things you've learned in chemistry from your secondary school, you get to understand that there are basically 5 different oxidation reactions. But the best to describe a substance that is oxidized is A, when a substance loses electron. Okay, so our number 2 answer will be A, when a substance loses electron. Question number 3. A blue litmus paper turns red when dipped into a solution. What does this indicate about the solution? A, the solution is basic. B, the solution is neutral. C, the solution is acidic. And D, the litmus paper is faulty. Now, from what we get, we know the litmus paper is not faulty because we were told from the beginning that a blue litmus paper turns red. Now, there are basically 2 types of litmus paper. We have the blue litmus paper and we have the red litmus paper. Now, they said a blue litmus paper turns red. And of course, a red litmus paper will turn blue. But the blue litmus paper will only turn red when the solution is acidic. So what it tells you is that an acid can turn a blue litmus paper red, and a base will do the opposite of an acid. It will turn a red litmus paper blue. So our number 3 answer will be C. So I'm coming here and giving you C. Question number 4. Question number 4 talks about which of the following compound is an example of an electrovalent bond. Electrovalent bond. Electrovalent bond basically is the same thing as an ionic bond. Now, if you remember, there are basically 2 types of bond. There is the electrovalent bond and there's the covalent bond. Now, the electrovalent bond, which is also can be regarded as ionic bond, is the transfer of ions, while the covalent bond is the sharing of electrons. Now, the following compound, which is an example of electrovalent bond, let's take a look at A. A says sodium chloride. Now, we have the NaCl. I'm going to write that, please. NaCl, sodium chloride. B talks about the carbon dioxide, CO2. C, we have the H2O, our normal water, and H2O, and D, the methane. From the look of things, if you've studied your chemistry through, you found out that, yeah, you have the transfer of electrons. You have the transfer of electrons. Ions are shared between sodium and chloride. So without wasting much time, our answer for number 4 will be A. All right, that's where you have the transfer of electrons. Remember, I told you, ionic bond is the same thing as electrovalent bond. All right, let's go to the next one quickly. Question number 5. Question number 5 talks about a gas. If a gas has a molar mass of 32 grams per mole and gas B has a molar mass of 64 grams per mole, what is the ratio of the diffusion rate? This is so simple, so easy. Just go to ratio. Let me clean this again quickly. Sorry. All right. Ratio we have first 32 and 64. So I'm going to give you 64 over 32. When this is divided, you're going to have 2 over 1. If you say ratio, we're talking about 2 is to 1. Now, if you take a look at our options quickly, we have A, 2 is to 1, B, 1 is to 2, C, 1 is to 1, and D, 1 is to 4. Our answer is A. So question number 5, we have A. Then question number 6. The contact process that is used for the industrial production of dash is clear. If you study your acid-base reaction and you study the process of making acid, you find out that one of the easiest acid that can be made is what I'm about to mention. But before I do that, let's give an option. A, you have sulfuric acid. Now, sulfuric acid is what most people look at and tell you the tetraoxosulfate 6 acid. Now, let me quickly bring up something here. I'm sure a lot of you should know that whenever you have this, and hydrogen begins this, you don't have to pronounce the hydrogen. You just have to start with the tetraoxosulfate 6 acid. Then the next one you have is the hydrochloric acid, the HCl. Right? The next one you have is the sodium hydroxide. The sodium hydroxide. And the last one is the calcium oxide. Now, in all 4 of these, one of them can be produced using the contact process. And the easiest one that can be produced using the contact process is the first one I just mentioned, the H2SO4, the sulfuric acid. Our answer is A. Question number 7, quickly. Now, which of the following is a unique property of water compared to other liquid? Now, there are several other liquids out there, but water is very unique. Let's take a look at our options quickly. A, it is a poor solvent. B, it does not evaporate. C, it expands when freezing. And D, it has a low heat capacity. Our answer is C. It expands when freezing. So question number 7, I have C. Question number 8. Sodium reacts vigorously with water to produce dash. Sodium reacts vigorously with water to produce dash. A, sodium chloride and oxygen gas. B, sodium nitrate and water. C, sodium hydroxide and hydrogen gas. And D, sodium oxide and hydrogen gas. Now, if you take a set sodium react vigorously with water, I will clean this up and write a small equation that will help us to understand how we're going to get our answer. Now, if you take a look at it, sodium reacts vigorously with water. I'm just going to make a simple equation on it. Now, what you see there, you're going to have the NaOH plus the H2. Now, with this, I think I've given you guys a clue of what my answer is supposed to be. I told you, I gave you options. Let me quickly hit you the options again. Sodium chloride and oxygen gas, that's A. I said sodium nitrate and water, that's B. I said sodium hydroxide and hydrogen gas, C. And D, sodium oxide and hydrogen gas. Now, take a look at that. I am sure you know that's my answer. Yeah, sodium hydroxide and hydrogen gas. Hydrogen gas is just smiling at us, looking at us. So yeah, I'm looking at you. I can see you. All right. So quickly, we're going to go to question number 8. What's our answer? What's the answer? You remember? Yeah. C. Thank you. Some of you are following me. Thank you so much. Now, question number 9. I just like this question. At room temperature and standard pressure, chlorine gas is in which state of matter? At room temperature and standard pressure, chlorine gas is in what state of matter? Now, A, the plasma. I like to bring out something a bit funny. I asked the students, what's the nature of fire? And they're like, fire is gas. I said, are you sure? I think I like to leave that to you to think about. What's the nature of fire? Is fire solid, liquid, or gas? I'm not going. I saw something now that maybe brought that up, but I'm not going to say anything about it. Go and research. All right. Now, A, I said plasma. B, solid. C, liquid, and D, gas. Now, of course, my answer is D, but I want to add a little thing added to that answer. It is not just gas. It's a choking greenish yellow gas. A choking greenish yellow gas. So a case might come that a question might be given to you and you're wondering, okay, I know it's something, but is it what? you could use this. All right, a choking greenish yellow gas. So let's go there. So our question number 9 is D. All right, question 10. All right, question 10. All right, what is the molecular geometry of a molecule with 3 bonds pair and a lone pair around the central atom? A 3 bond pair and a lone pair around the central atom. Let's write that. Yeah, let's write that. Let's take a look at that. Yes, that seems interesting. They said, what is the molecular geometry of a molecule with 3 bonding pairs and no lone pair around the central atom? A, we have the tetrahedra. B, we have the trigonal planar. And C, we have the linear. And D, we have the octahedra. Now, they said one is in the middle, a lone pair in the middle, and you have this. That looks like something that is giving you an angle of 120 degree. Yeah, that looks like something that is giving you an angle of 120 degree. And if you take a look at that, it looks like something that is practically giving you a triangle. It looks like, yeah, it looks like that. So if we take a look at that, your B option seems most appropriate. Now, electron pair themselves around this. Electron pair themselves around a lone pair atom like this. One, to minimize repulsion. To minimize repulsion. And also to form a 120 degree angle. So our answer on number 10 question is going to be B. Question number 11. I love this question. I just love this question. Isotopes of an element have A, the same number of protons but different number of neutrons. B, the same number of neutrons and electrons. Let's go on. C, the same number of protons and neutrons. D, the same number of protons and electrons. Now, I usually tell students, isotopes are like twins. All right, you have in Nigeria. Let's don't give me a headache of Nigeria. So they're like twins. You have the other side of the element. So for you to easily understand it, go to look at the answer on A. The same number of proton but different number of neutron. The same number of proton but different number of neutron. If you take a look at that, the same number of proton but different number of neutron. Now, if you follow the electronic shell that we have, now we have the nucleus in the middle. Now we have the protons and neutrons. Let's pick a particular element. Yeah, let's pick an oxygen element, for instance. Now we have an oxygen 8, and we have that is atomic number 8. All right, and we have a mass number 16, right? So now we have mass number. Now atomic number is the same thing as the number of protons and electrons, and mass number is the number of neutrons. So now, if you want to follow properly through your question, your answer is clear. You have A as your answer, because number of neutrons is the same thing as mass number. And I told you isotopes are like twins. They have the second side. So if I'm considering, which oxygen is, of course, it's not an isotope element. If I'm considering oxygen as an isotope, it will have another element is there. It will have 8 also, and it will have maybe possibly 17. You get the picture, right? So this is an example of how an isotope works. So our answer is 8. Question number 11 is A. Now, question number 12. Question number 12. Which element is placed at the top of the electrochemical series? Which element is placed at the top of the electrochemical series? Now, elements are basically placed at electrochemical series because of their electrode potential. So let me take care of this. So I could just write something on the board quickly for you guys. Sorry. All right. Now, elements are placed on the series because of their electrode potential. 1. Now, also their decreased reactivity. And the last one is ease of oxidation. Now, I think you remember something I said about oxidation earlier. from maybe our question 1 or question 2 from the beginning. We talked about oxidation. So it means this element should be able to lose electron easily. Yeah. So how do you now know which element, according to the options we have here in the chemical series, are at the top? First, you have A as copper, B, you have your hydrogen, C, you have your sodium, D, you have your oxygen. Sodium comes out sparking. Sodium comes out shouting. It's clear. Sodium is telling you, I am the one. Hello, sir, I'm the one. You can't avoid it. So our answer, question number 12, will be C. Question number 13. This is nice. Which transitional metal or transition metal is known for its multi-colorful oxidation state and compound used in pigments and paints? Now, transition elements are quite interesting to understand. Very interesting. If you take a look at the periodic table, I have to clean this again. Hope you're not writing. If you're writing, I think you have to be very fast. Okay. Now, I'm going to draw a small sketch of my periodic table. Forgive me, it's not going to be as beautiful as you want it to see. So now, in the periodic table, you have this, and take you now something like this, then this, and this. I may clean this, move this a little. Now, from that, you have a 1, a 2. Okay, let me put a number. Let's leave Roman figure. Then you have a 3, a 4, 5, 6, 7, and the last we have a 0. Now, this is just, sorry, my sample of the periodic table. You'll not be offended. That I cannot draw. I accept. All right. Now, for what you see in this part, if you remember that, also, I think there are 2 other small things here. The inner transition element, the lanthanide and the actinide. Yes, that's so. Now, this part is basically referred to as the transition metals. Now, metals that are known for their ability to have multiple oxidation states. More than one multiple oxidation state. Some can have up to 3 oxidation states. One of them that can do that so easily is copper. Take a look at our options. A, silver. B, copper. C, gold. And D, zinc. And copper shows the quality of everything that is asked in the question. I showed you a question, transition metals that is known for their colorful oxidation states, and used as pigment and paint. Copper is no exception to this. Copper stands out first. It's telling you, I am the one. You cannot deny it. It has a wide range of oxidation states, +1, +2, +3, and it has, of course, a very nice unique colors. So our answer for this on question number 13 is B. Question number 14. Which of the following method is commonly used to remove suspended impurities from water? A, fluoridation. B, chlorination. C, filtration. And D, distillation. Now, there are other methods that are involved, but I think the one that comes out the most should be our C, filtration. Now, there are other methods like the, I think I need to keep playing this. There are other methods like the sedimentation method. There's other method like the coagulation method, and there's another method like the flocculation method. Now, but all this is not our issues. Our focus on this. So, like I told you, the A is fluoridation, B, chlorination, C, filtration, and D, distillation. Our answer is C, filtration. It is easily used and it's the best method to use to remove impurities from water. So number 14 gives me C. Question number 15. What is the valency of an element with electronic configuration 287? I will explain something here that I think is important because people miss the word oxidation and valency. Now, oxidation comes with the positive and the negative sign, but valency doesn't do that. Now, let's take elements, for instance, any element that comes to mind. Let me give you, like what I see here now. I have the 287. If you follow this and you want to put them in the electronic configuration shell, right, the KLM, all right, you have the 288, right? Now, if you take a look at this 8 and this 7, you can find that you can see that you just need 1 year to complete. and it's not complete. So because you need one more year to complete, it means it needs electron. It needs to be balanced. It is not balanced. It has 7 and it needs one more to be balanced. And element can exist as electron donors or electron acceptors. Now, from this is an electron acceptor. So it means it needs a plus, a 1. Now, if you want to follow properly, it needs a 1 to come in, and it's going to be a -1. But I told you something earlier as I was trying to explain this question. I said something about oxidation and valency. I said oxidation will give you a -1. That's the oxidation state. Valency will just tell you 1. All right, so don't get confused when you see the question. You say, but it needs 1. I'm seeing a -1 here. Our answer says 1 here. No. Valency will just tell you without the sign. Oxidation will come and tell you there must be a sign. Either it's a positive, not a negative. Element that tends to want to accept electrons, all right? Accept electrons usually comes with an oxidation either as a negative, all right? An element that tends to donate electron comes with an oxidation with a positive. All right, so let's go on. So our question here: A 7, B 1, C 2, and D 3. That's so simple. 15 is B, which is 1. Number 16. All right. When an hydrous cobalt chlorine paper is exposed to water, what color is changed? Is observed. Sorry, what color change is observed? Let me take that again. When an hydrous cobalt chlorine paper is exposed to water, what color change is observed? A, from pink to blue. B, from white to blue. C, from blue to white. D, from blue to pink. Now, I wrote something here quickly which I want to show you guys. I said an hydrous cobalt chlorine paper is used as a moisture indicator and is often used as weather instrument to measure humidity. Did you get that? Let me give you again. An hydrous cobalt chlorine paper. So it's more like a litmus paper, but not a litmus paper, but its own kind of paper. It's used as moisture indicator and also often used as weather instrument to measure humidity. Our clear answer here is blue to pink. D. All right, so we go to number 16, D, with number 17. All right, we're almost there. All right, let me do this. Okay. What type of salt is found in anticide medication and is used to relieve heartburn and injection? Or that is the word indigestion. That's most people say it's injection, some people say indigestion. So which one works for you? Just take it. Okay, so let's move on. A, aluminum chloride. B, magnesium chloride. C, sodium chloride. And D, calcium chloride. But sir, your answer is not there. What is sodium bicarbonate? Calm down. Now, the best option there is sodium chloride. Now, if you take a look at anticide medications, what you have more there is sodium bicarbonate. But according to the question given to you and the options that you have here, your best option is sodium chloride. So you stick with C, okay? Sodium chloride. That's question number 17. It is C. Question number 18. All right. What is the atomic number of aluminum? I smiled immediately I read this question. Like, why are you serious? Atomic number of aluminum? Really? Aluminum on the table is number 13. Its atomic number is 13. Okay, I didn't give you the options. So let me give you options. A, 13, B, 26, C, 14, and D, 12. Aluminum is number 13. It's just so simple. Like he's saying 1 plus 1. That is just so simple. So aluminum is number 13. All right, so I will have our A here. Number 19. Which of the following metal is a common alloy with copper to make brass? A, iron. B, nickel. C, aluminum. And D, zinc. Now, if you take a look at our options, the best option there is zinc. Our answer there is zinc. It strengthens and improves copper. Okay, let's go on. And also helps in corrosivity. Now, our answer there is D. And question that will round up what we're doing for today, for now, question number 20. What happened when an aconic acid react with alcohol in the presence of an acid catalyst? When an alcoholic acid reacts with alcohol in the presence of an acid catalyst. A. Sponification. B. Esterification. C. Polymerization. And D. Hydrolysis. Basically, our answer here is also B. That is the only reaction that can give you that. That is the reaction that can give you that. An ester with water are basically produced. So our final answer on question number 24 now is B. Now, before I round up our class, I like to bring up something I said from the beginning. Hope you guys remember what I told you. Our case study exams. Please go to Play Store. Yes, with an X, please. Go to Play Store, download, and enjoy. See you guys.